under forced vibration, it will now oscillate with the frequency of the external force. समझ आ गया? What is frequency of external force? How many times you are pushing per second? That is the frequency of the external force. The number of times you are pushing the oscillator per second. Is that clear? So now the oscillator will oscillate with this frequency of the external periodic force. Okay. So this is a forced vibration. Now you'll have a sustained vibration. Okay. So ये जो damped oscillation है वो कैसा था? Its oscillations are reducing with time. Oscillation meaning the amplitude. Okay, amplitude means displacement of the oscillator on either side. Displacement. ठीक है. तो reduce होते होते zero हो जाएगा एक टाइम के बाद. तो अगर मेरे को इसको सस्टेन करना है तो फोर्स्ड ऑसिलेशन में कैसा हो जाएगा अभी? Whatever energy is lost, that is supplied back by the external force. ठीक है? तो ये जो वाइब्रेशन है, फ्री वाइब्रेशन मेरे को ऐसा मिलेगा, इसमें एनर्जी लॉस नहीं होगा. ठीक है? तो ऐसा वाइब्रेशन मिल रहा है कैसे? रियल लाइफ में इन केस ऑफ फोर्स वाइब्रेशन. ठीक है? अब और एक टाइप का होता है which is called resonance. So what is resonance? This is also a forced vibration. Resonance is also a forced vibration. Vibration taking place under the external periodic force. In this case, it is a forced vibration, in which case the applied periodic force frequency matches the natural frequency of the oscillating arm. तो उसको हम क्या बोलते हैं? Resonance. So resonance is a special case of forced vibration in which the frequency of the applied external periodic force matches the natural frequency. तो होता क्या है फिर? Then we get, this leads to vibrations with large amplitude. Okay, this will produce vibrations of large amplitude. This is what happens in the swing when the mother pushes almost equal to the frequency of the swing. Then it really swings with a very large amplitude. Okay, so that is resonance. Now this has many practical applications in real life. Okay, like chorus. When people sing together, a group of people singing at a low pitch, but when it combines and everybody's frequency matches, a loud sound is produced.
Earlier there used to be opera in which they used to play
You got what is the application of resonance? There is another application of electrical resonance. Like when the broadcast, there are studios which are broadcasting. So when you tune, so basically in the atmosphere, there are so many people who are broadcasting. Many stations are broadcasting. Let's say a radio, okay? You have one transistor set, but you can tune it to different stations. So what do you do during the tuning? You are changing the frequency. So when the frequency of your transistor matches the broadcast frequency, that signal is picked, because corresponding to that signal, a high current is produced in the transistor, which is then fed to the speaker, amplified and fed to the speaker. Okay, so tuning is application of electrical resonance. Sound के केस में मैंने बताया, जैसे orchestra playing or chorus. Okay, that way. Also, now there are certain experiments. ठीक है? So इसमें resonance का जो experiment है वो मैं तुम्हें बताता हूँ यहाँ पे. Look at this experiment. In your book, you have this experiment. So what is resonance here? देखो. You have a tuning fork. Everybody look here. You have a tuning fork. Okay. So every tuning fork has got a frequency printed on it. Everybody has seen tuning fork in the laboratory? Yeah. Okay. So you must have noticed the frequency of the tuning fork is printed on the tuning fork. So let's say it is 250 hertz. Again, it is generally printed on the tuning fork. So whenever you vibrate this tuning fork by hitting on a rubber band, so it will vibrate with this frequency and it will produce a unique sound. Every time you hit or set the tuning fork in vibration, it will produce a unique sound. Okay. Now when the tuning fork is vibrating, that time what you do? You place it on a sound box. Okay, so what is the sound box? Sound box में one of the wall is not there. So what I've done here is these vibration will vibrate the air inside the sound box. Okay, and this side is open. This side of the sound box is open. So this air also begin to vibrate with the same frequency. इसके अंदर it's a hollow box, okay, with one wall open on the right side. So the air will vibrate and the vibrating air will move to the similar sound box and non-vibrating tuning fork present there. This tuning fork is identical. Okay, this tuning fork is identical. मतलब इसका भी frequency कितना है? 250 hertz. तो होता क्या है? This vibration transmit the vibration. The other box के अंदर का air also begins to vibrate with the same frequency, and that transfers the frequency to the tuning fork. So this second tuning fork also begins to vibrate at the same frequency as the first tuning fork. Since both are identical, so they are vibrating at the same frequency and a loud sound is heard, depicting resonance. Loud sound means frequency is same, but now the amplitude is more. Okay, so when the sound is loud, frequency does not change. What increases just the amplitude, right? In this pendulum, if you leave it from a bigger amplitude, frequency does not change. Frequency will be this only. There is no amplitude here. Okay, so when you hear a loud sound, like it has lot of energy. Oscillation is same, like vocal cord is oscillating with the same frequency. How am I able to produce sound? Due to the vibration of my vocal cord. Now this vocal cord has unique frequency. So every time I am speaking, you are hearing the same distinct voice. But when I apply a lot of energy, then I really talk at a very high, loud sound, means lot of energy. So I will not be able to speak with this loud sound for a long duration. Because energy I will be drained out. Frequency same है. तो साउंड तो अभी भी वैसे ही है, लेकिन अब क्या हो गया? लाउड हो गया. Understood? Understood now how the resonance is depicted here. How resonance is depicted? Everyone has understood? Am I asking?
Yes.
Huh? Can you explain what did we do here? All of you have understood, I guess. Explain how resonance is taking place here. Give them chance. I want this guy to speak. What's your name? हाँ? लक्ष्य लक्ष्य दिया था क्या जब मैं ये बता रहा था तुम्हें? बताओ.
When body starts vibrating,
Which body starts vibrating here? Be very specific.
the box and
The box. How the box vibrates? Yes, Vedoshita.
Whether you want less, but vibrating for.
So first we set this tuning fork into vibration. Then it is placed on the box. And then what happens? Vibrate. Correct.
Very active.
That vibrating air vibrates the adjacent air molecules. That's how it reaches the air of the next box, which causes the surface of the box to vibrate. Which causes the tuning fork to vibrate at the same frequency. Now these two tuning forks are now vibrating at the same frequency, which satisfies. So this is the force vibration. This tuning fork is forcing the air to vibrate. So this is force vibration. This is forcing the box to vibrate. That is forcing the tuning fork. So now the forced vibrations are such. These two are equal. For the second tuning fork, the force vibration is of equal frequency. So the two tuning forks are now vibrating at the same frequency, which satisfies the condition for resonance. Okay, so that's why what is heard. How do you acknowledge that resonance has taken place? Suddenly you will hear loud sound. Clear? That's it. Okay. Then we have another experiment. What is the experiment here? We have 4 pendulums. We have 4 pendulums A, B, C, D. So where are these pendulums hanged? This is a rubber shaft or rod, you can say. Means it is not rigid. It's made up of rubber, hard rubber. Okay. So now what is happening is, now this pendulum is set in oscillation. What is done here? Pendulum A is set into oscillations. So this will twist this rod. Correct? So this rod is not a rigid thing. So if any oscillator fixed to this, will also bend it a little bit. So with this, the vibrations will be passed further. All of them begin to oscillate now. Now you can see for pendulum A and C, the length is same. Correct? So when all of these begin to vibrate, okay, so their frequency of vibration will be identical. So A and C will vibrate with large amplitude, whereas B and D will vibrate with small amplitude. When periodic external force is not equal to natural frequency, then the vibration take place with very small amplitude. Okay, even smaller than the natural vibration. Okay, is that clear? So this is how A and C demonstrate resonance. So many questions are asked. What is the nature of vibration taking place between pendulum A and C? We'll say force vibration and resonance. Resonance is also force vibration, but now it has a. Whereas B and D, what kind of vibrations are taking place? Only force vibration, but not resonance. B and D are also oscillating because of the vibrations initiated by A. So they are forced vibrations only. Whereas C is unique. It also has resonance. Is that clear? Okay, so just keep this.
So, the vibration for A pendulum and for C pendulum will be equal.
Yes.
The amplitude also.
Equal because the pendulum का frequency depends on only the length.
Length of the string.
और लेंथ दोनों का हमने सेम रखा है. समझ में आएगा? तो डायमेंशन पे डिपेंड करता है फ्रीक्वेंसी, शेप एंड साइज. तो सब कुछ सेम है, बाकी की लेंथ अलग है, इसलिए तो सेम फ्रीक्वेंसी में मैच करेगा. ये फोर्स कर रहा है सी को, तो सी में भी फोर्स वाइब्रेशन, लेकिन अब सी अपने नेचुरल फ्रीक्वेंसी से ऑसिलेट करेगा. इसका फ्रीक्वेंसी इसके लिए फोर्स फ्रीक्वेंसी हो गया, तो ये फोर्स और नेचुरल मैच हो गई. समझ गया? ठीक है. जैसे अभी ये हंस रहा है लेकिन तू हंस नहीं रहा है, तो ये कोई रेजोनेंस क्रिएट नहीं कर पाया. जैसे किसी एक ने हंसा और सारी क्लास हंस पड़ी, तो वो क्या हो गया? रेजोनेंस. तो ये इसका फोर्स वाइब्रेशन में दम नहीं है. मतलब अगला your vibration is going to die very soon. ठीक है. अब देखो और एक एक्सपेरिमेंट है. ये क्या एक्सपेरिमेंट है? अब इसमें रेजोनेंस कैसा होगा देखो. यहाँ पे ये 2 water cylinders. Yes. So you know that यहाँ पे एक water reservoir है, and this is connected with a pipe here. You know that water will exist at the same level, right? So you can change the height of the water column here by raising or lowering the reservoir at the right side. ठीक है. तो ये हम क्यों यूज कर रहे हैं इसको? This is how it is fixed here. So what you can do is you can raise or lower the height in the of the water reservoir. तो उसकी वजह से क्या होगा? यहाँ पे जो एयर कॉलम है, एयर कॉलम क्या बन रहा है देखो. So you understand that this is actually clamped here. It is clamped. This is clamped from outside. Okay. So this one is fixed. ठीक है. So basically, now what you will do is you want to experiment for resonance, right? So resonance में क्या होगा? Loud sound सुनाई देना चाहिए. So what you are doing is you are keeping a vibrating tuning fork here. There is a tuning fork which is vibrating, and you are keeping it above the this fixed water cylinder which is carrying water. So initially the water is till this level. Okay. Now when you lower this, right? दोनों में same level. When you lower this, तो ये भी कहाँ जाएगा? नीचे जाएगा. ठीक है. So at a certain length of air column, let us say this is L1. You will hear a loud sound. You will hear a loud sound. Loud sound कब होगा? When the air here vibrates at the same frequency as tuning fork. तो ये हो गया first resonance. ठीक है. अभी तुम इसको और नीचे लेके जा रहे हो. ठीक है. Next loud sound फिर से सुनाई देगा. वो कब सुनाई देगा? At 3 times the length. Next loud sound कब सुनाई देगा? L2 ये जब 3 times L1 है, समझ में आया? 3 times पे फिर से रेजोनेंस नहीं रहेगी, मतलब 1:3 ऐसे ये रेशियो में आता है, 1:5 ऑड मल्टीपल से आता है। उसके बाद और एक रेजोनेंस आएगा 5 टाइम्स के, मतलब जो भी तुमको रेजोनेंस सुनाई देगा वो 1:3:5 ऐसे लेंथ पे सुनाई देगा। बात समझ में आ गई? तो ये बाई एक्सपेरिमेंट यू आर ऑब्जर्विंग, राइट? बट इसका थ्योरी तुमको 12th स्टैंडर्ड में है या फिर 11th स्टैंडर्ड में है, ठीक है? तो ये हो गया तुम्हारा रेजोनेंस का डेमोन्स्ट्रेशन एक्सपेरिमेंटली। क्या बताया मैंने? जो एयर का कॉलम है, बेसिकली बाय लोअरिंग, इंक्रीजिंग और डिक्रीजिंग द वाटर सरफेस, तुम क्या कर रहे हो? यू आर इंक्रीजिंग और डिक्रीजिंग द कॉलम ऑफ एयर। तो ट्यूनिंग फोक तो वही फ्रीक्वेंसी से वाइब्रेट हो रहा है, लेकिन अलग अलग लेंथ पे, है ना, एयर सेम फ्रीक्वेंसी से वाइब्रेट होने लग जाता है, तो मल्टीपल रेजोनेंस आर क्रिएटेड। तो इस केस में तो लेंथ का रेशियो क्या मिलता है तुमको? 1। हाँ, मोर द, हाँ नहीं, उसका कैलकुलेशन अलग होगा, अब एयर कॉलम का लेंथ का अलग होगा, ठीक है? फ्रीक्वेंसी इज लीस्ट, दिस इज द लीस्ट फ्रीक्वेंसी। जैसे तुम आगे जाओगे, नहीं एनर्जी, एनर्जी
AC